In this lesson, we're going to take a look at our DNA as a molecular clock foldable. This goes along with our notes on evidence of evolution. Remember, when we talk about the theory of evolution, we're talking about the theory that it tries to explain how living things change over time, how populations of living things change over time. And one of the best pieces of evidence that we have for this theory is using DNA. So what we're going to do here for this activity is I have cut out my little background right here, right? So my directions, they tell me to cut out, right, the segments of DNA. So I have already cut out all 5 of those segments, A, B, C, D, and E. Cut out the timeline, right? So that's what I've done here. I've cut out the timeline. I've glued it onto a page in my notebook. On the bottom of the timeline is the DNA segment of the same gene of a common ancestor to the 5 species. Okay, so there's my common ancestor. So we need to compare the DNA segments of all of these species to the common ancestor's DNA. And we're going to color or shade each letter or nucleotide that is different from the common ancestor's DNA. If one mutation occurs every 1 million years, determine when each species evolved. So for example, if species A has 2 mutations, it evolved 2 million years after the common ancestor. Okay, so we'll glue the DNA segments of the species to the timeline to show when each species evolved. And then based on when the species evolved, okay, so we'll answer a couple of questions. All right, so the first thing I need to do is I need to highlight, right, or color the nucleotides that are different compared to my common ancestor. Okay, so I'm just going to basically place species A next to my common ancestor. All right, so the first one's different, so that was easy. So just highlight that one. Second one's different. This one's different. G, A, T, C, G, G, A. Okay, so that one has a bunch that are different. All right, species B. These are so far, oh, there's a different one. A, T, C, G, G, A, T. All right, well, that was easy. Species C. All right, different, different. T, C, T, T, A. This is different. Okay, so only a couple one for species C. Species D, all right, should be an A, that should be a C, C, G, T, T, and that's an A. This should be an A, G, G, T, A, T, C, G, that should be a G, all right. And then last but not least, species E. Okay, that one's different, that one's different, C, G, T, T, A. That should be an A, C, G, T, A, T, C, G, G, A, T. All right, so there we go. So now, right, so they're saying if for every, right, if species A has 2 mutations, it evolved 2 million years ago. So, all right, so I'm just gonna start here because that was the last one. So species E has 3 mutations. So I know that it evolved around 3 million years ago. So I'm just going to put a piece of tape, right, to secure that right there. Species A has 1, 2, 3, 4, 5, 6 mutations. So it evolved 6 million years ago. Throw a piece of tape onto that. All right, 1, 2, 3. I feel like I made a mistake. These probably shouldn't be the same. Let me double check myself. T, A, C, G, T, T, A, T, C, G, T, A, T, C, G, G, A. Ha! I did miss one. Look at that. This last one should be a T. It's not. All right, it's an A. All right, so this one has 4. Haha. Look at that. So 4 mutations means 4 million years ago. All right, we only have one mutation here. There we go. And then 1, 2, 3, 4, 5, 6, 7 mutations for species D. So that's going to go up here. There we go. Now I have my molecular clock, so I can see, right, how closely, right, or distantly these strands of DNA are related to my common ancestor. So their question is, based on when the species evolved, which species is most similar to the common ancestor and which is the most different? So species B is going to be the most similar, right, because it only has one nucleotide difference. And species D, right, is going to be the most different. Which again, when I think about it kind of logically, species B, right, evolved 1,000,000 years after the common ancestor, whereas species D evolved 7,000,000 years after the common ancestor. So it kind of makes sense that, yeah, this species, it evolved so much farther away. So yeah, it would be really different compared to my common ancestor. So this is a good example of how DNA can be used, right, to show similarities and differences in the evolutionary history of different organisms.